So a little bit about me, the obligatory I love me slide. As you saw in the first slide up here, I was originally scheduled to give this talk with my collaborator, Gerie Owen. Gerie is not here right now. She's with us in spirit, but she broke her leg in a couple of different places about 2 weeks ago and just underwent surgery yesterday. So she's devastated at not being here. We were both here last year and we greatly enjoyed it. We're hoping to hear from her tomorrow via electronic means to give her presentation, and I will be there to help out with that also. So a little bit of an agenda. I don't know if I'm quite going to follow this agenda or not, but here are the things that I've been thinking about. One of the things that I'd like to talk about when I talk about making disaster routine, you must be thinking, well, what does this really mean? So I started thinking a while back about the influence that air crews, flight crews can have on other types of teams. I was a private pilot when I was 17 years old. I think that was about 5 or 6 years ago. You didn't have to laugh, really. But I slowly moved away from flying. But one thing struck me earlier this year, and that is in the United States, where I come from, the Boston area, in the United States, U.S. air carrier, there was a U.S. air carrier fatal crash in 2009. There was also a fatal crash or a fatal accident, I should say, in 2018. Between 2009 and 2018, there was not a single fatality that happened on a U.S. air carrier. They must be doing something right. And I'd like to talk a little bit, in looking at disaster, I'd like to talk a little bit about how air crews actually can handle disaster and how that can be applicable to DevOps teams too. I actually have a presentation. This is kind of a follow-on to that one. I have a presentation on what air crews can teach DevOps teams. I'm actually giving that at Agile DevOps East in Orlando, Florida next week. And this is kind of a follow-on. This got me to thinking about how we can respond better when things go wrong. So what is DevOps? DevOps, I don't remember where I got this definition, but DevOps, I think, was from Wikipedia. Containerized development, rapid iteration with real-time performance insights, intelligent feedback, diagnostic services, an integrated DevOps pipeline, and deployment to the cloud. Bože můj. But what does that mean in layman's terms? That's quite a mouthful. What does that mean in layman's terms? Is that we automatically integrate and build every time there's a valid check-in. We don't wait. We run automated tests at all stages, including in production. We send the app to production in an automated fashion. When it's been integrated and tested, those tests are almost always of an automated variety. They might be smoke tests, they might be unit tests, but they're almost always of an automated environment. And last, I've used the word automation a couple of times here. Automation makes it all work, all of this work, like a Swiss watch. So what's a disaster? I pulled out from this definition that I got 3 key points. First of all, it's a disruption. It's something that has gone wrong. It's disrupted our normal way of working and acting. It occurs in a short time frame. It happens suddenly, and hopefully it's over in a relatively short period of time too. I have my older sister lives in a town in the state of North Carolina called Wilmington. It's been in the news a bit lately. In September, they had the first hurricane direct hit that they've had in about 19 years. And that was certainly a disaster. It was a disruption, but it's something that even with preparation, even with rapid response, is going to take some of them months, perhaps even years to recover from. It exceeds our ability to cope. we're overwhelmed, either with work that needs to be done, challenges that need to be faced, problems that need to be solved, actions that need to be taken, and things like that. So it actually exceeds the abilities of us as individuals and us as members of a team also. So let's apply that. Let's try to apply that to DevOps. I think a disaster for a DevOps team and in application DevOps application development deployment is our consistency. Our automation becomes uncertain. The automated workflow breaks down in some way, shape, or form. Builds start to fail. Perhaps smoke tests are blocked. Server farm goes offline in production. The application won't start again, or we might have a showstopper bug in production. Anything that disrupts that consistency can be considered a disaster. We tend, especially as software people, we suffer from a little bit of instant gratification. If we want something, we go off and build it. We go off and buy it. We do whatever. My cell phone died last week. I went out. I was actually on my way back from Spain. I landed Sunday afternoon. I went immediately to the phone store and got another phone. So we don't respond well to disasters. We have a little bit of that, as I said, the instant gratification. So when things start to go wrong and we don't understand what they are, we have a measure of disbelief. We're uncertain about what went wrong and what to do about it. And in some cases, we even panic. So what can we do to prepare for the unknown? As I mentioned, this is a follow-on to my presentation on what air crews can teach DevOps teams. I'd like to pull an example from that, and that was U.S. Airways Flight 1549. I believe that was in 2015, often called the Miracle on the Hudson. Does anybody remember that? A few of you, many of you actually. Okay, good. So this is an aircraft, an Airbus 320 that took off from LaGuardia Airport in New York City. 1 minute and 20 seconds into the flight at an altitude of 2,700 feet, it had a bird strike with an entire flock of large Canadian geese. Both engines flamed out. And what happened is that they managed to not get back to the airport. They didn't manage to get back to the airport or any other airport in the New York area for that matter. But they managed to miss all of the buildings, all of the highways, and land right in the middle of the Hudson River without a single fatality. Now there's some lessons to be learned with this. Captain Sully Sullenberger and First Officer Skiles had never met before that day. That still amazes me. They met for the first time that morning. Nope. I think that might be me here. Yeah, pull it out. There we go. Okay. Let's keep on going. Okay. No, we lost it again. Okay, don't memo to self, don't touch the computer. Yet they worked, when things went wrong, they worked from established procedures. They practiced throughout their careers for hundreds of hours, and they immediately turned to their checklist. Air crews have a checklist for everything. They may not exactly apply, but they understand what they're going to do precisely whenever disaster strikes. And as I point out here, 90 seconds after that bird strike and the engines flamed out, they were in the Hudson River. You have to practice this. You have to understand precisely what you're doing and make instantaneous decisions. And I listened. I realized it wasn't possible to do audio here. But if you go to YouTube and type in "Miracle on the Hudson" and get the full cockpit recording, you'll find out that they were so calm, so cool, so collected that somebody wrote, it was like Captain Sullenberger was ordering a cup of coffee. No panic, no indecision, no disaster. He just says, in a normal tone of voice, we're going in the Hudson. So we can learn from air crews. Indecision, especially indecision and panic, are killers. Our checklist. How many of you use checklists in your DevOps practices? Any of you? A few of you. That's a good sign. I think that we need to develop checklists more. They drive our decision making by focusing on the essentials. More and more in hospitals, more and more surgical teams are also using checklists, and they're saving lives. With air crews in commercial aviation, checklists are saving lives. I believe that in DevOps teams, checklists may not save lives, but they'll certainly save a lot of time and heartache. Your course of action are defined very quickly. You know what, you just pull out the appropriate checklist, server farm goes down, 1, 2, 3, it tells you what to do. The course of action is defined really fast, increasing the probability that you're going to come up with a solution faster than you would otherwise. And the way I like to word it is that checklists and practice make disasters just another day in the office. Nothing's different. Everybody responds in a normal tone of voice, yet we know something's wrong, something's been disrupted. We have a disaster, but by responding as we practice, as we know how, it's just another day at the office. So how can we practice disaster? I have a couple of different ways: chaos engineering, failure scenarios, and application health monitoring. Do any of you use chaos engineering at all in your DevOps practices? There's one right there, about maybe half a dozen. Okay, yeah. Chaos, for those of you who haven't heard of chaos engineering, it was first practiced by Netflix. And Netflix would do things like pull entire network segments off of their server farm. They wanted to make sure they were testing their application, they were testing their delivery system for resiliency. They wanted to see how resilient it would be. So they practiced, for example, a distributed denial of service attack and see how their application would respond. And these are for production systems. These are systems that are actually serving users at the time. So as a result, they came up with a name for this, chaos engineering, and it's defined on a website called principlesofchaos.org. So if you want to read more about this, you'll find more about it on the website principlesofchaos.org. They describe it as an experimentation. So Paula, thanks for the setup there, talking about experimenting. They describe chaos engineering as a process of experimentation to uncover systematic weaknesses in their applications and in production. They want you, first of all, to define the normal behavior, what you expect the application to do. What's the steady state? Set the null hypothesis, which is that steady state, and an alternative hypothesis. We fail in some way, shape, or form. If you studied the scientific method, these steps are probably pretty familiar to you. Introduce variables that can reflect real-world events. Servers crash, hard drives malfunction, network connections are lost. And that's just a few of them. And try to disprove that you will continue in a steady state. You practice this in production, as I've pointed out. You vary the real-world events. Once again, this is a type of quality test, but we're testing quality in production, and it's a specific type of quality test. We're testing not necessarily for bugs or anything like that. We're testing how resilient our applications are to those real-world events. Yes, there could be customer impact, but it's incumbent upon the DevOps engineer to minimize if the application does in fact fail in some way, shape, or form. it's incumbent upon that DevOps engineer practicing that chaos to minimize the customer impact. But the point of the experiment is to find out if and when these things happen in real life, we're trying to minimize customer impact anyway. So practicing them beforehand gives us a lot of information on how resilient our application will be. Netflix called this Chaos Monkey, and it was a particular type of test. Now it basically caused breakdowns in their production environment. They could pull network segments offline. They can pull entire segments of server farms offline. It now consists of a variety of different tools, and it's called Simian Army. It's all about resiliency, as I pointed out. Can our application survive real-world events? We can also practice failure scenarios. We can do this in one of two ways. We can do this as a series of thought experiments, or we can actually write them down and simulate them happening in our production environment itself. Each team member should contribute to these failure scenarios. What's the worst thing you think can happen to our application? I guess the earth blows up or something like that. But no, it's what's the worst you think can happen? What would be your ultimate bad day? And have each team member describe a scenario that reflects their ultimate bad day. The more unlikely, the better, because guess what? Given enough time, just about anything will happen anyway. Write up these scenarios. Only the team leader will see them beforehand. They can be real failures that we simulate, or they can be thought experiments. Describe the scenarios to the team. Here's a simple example. Load is remaining constant, but performance is gradually deteriorating. We're starting to get 404 and related errors. The server farm also seems to be operating correctly. It's an application issue. Pings are slowing down, but not drastically. How are we going to diagnose and address this? And once you come up with your procedure, guess what you do with that procedure? You talk through it with the team, or you actually simulate it, but once you come up with that procedure, guess what you do with it? Checklist. And that's one of the checklists when things that you create and use when things start going wrong. I'm also against the idea, this is within the programmer and IT culture. Good programmers, great IT people, dedicated IT people want to be a hero. When something goes wrong, they want to solve it themselves, and if it takes all them being at the office all night, so be it. Heroes use superhuman efforts to fix a disaster. But in doing so, they break their communications, they break their connections with the rest of the team. Teams function together better. If a team has a hero, the team may not try as hard in the future. Your hero also is not replicable. Say your hero leaves, say your hero is out of the office that day for whatever reason, you haven't replicated it. And your hero can't solve every problem. No, I've never seen anything like this before. I don't know what to do. Third thing we can do is we can monitor application health in production. There are a number of tools to be able to do so. Amazon has a couple of different tools that enable you to monitor in production. So does Google Cloud. There are also third-party applications, third-party solutions such as New Relic, Dynatrace, AppDynamics, and companies like that. There are some smaller companies that do some very specific things. Jason, I think you're out there somewhere. Datadog's one of them, and Sumo Logic, LogDNA, companies like that. Still, the majority of the companies, even for applications in the cloud, Guess how they monitor the health of their application? They set up a continuous ping. That's all they do. Just, are you alive? Are you at 30 seconds later? Are you alive? 30 seconds later, are you alive? What you really need is comprehensive availability and performance and health data for your application in production. You can also do synthetic testing. Synthetic testing is just like testing that you might do for production. You have test scripts and you run test scripts and things like that. Synthetic testing, however, you're running those test scripts on the application in production. You may do a number of different things. You may have, for example, watermarks where you say, if this happens, immediate action is necessary. For example, 25% of pages take longer than 2 seconds to load. We have to fix that immediately. You can use artificial intelligence for prediction. Based on similar results in the past, the application is likely to fail soon. Analytics, big data is all the rage today, but collecting and storing data is cheap. We should make as much use of that data as we can. Checklists, I've mentioned checklists a couple of times here. They're part of our daily lives. They help us remember things. There was, once again, I'm going to go back to an air cruise example. There was a situation just a few weeks ago where a commercial airliner took off, and as it was climbing to altitude, people started having trouble breathing. They started getting headaches. Eventually, I should say passengers, eventually the oxygen mask fell. And nobody knew, none of the flight crew knew what was wrong. Guess what? They forgot to turn on the cabin pressurization. They've done it 1,000 times before, probably thousands of times before. It's something that you don't forget, yet guess what? Maybe they got distracted or something like that. They just forgot it. So they help us remember things. They organize our decision-making processes and can reduce risk in complex activities. There are a number of different types of checklists. We can have check mark, yes, no, signature type checklists. There's just a wide variety. I won't go through them all. How do we use these in DevOps? We can use them to replace test cases. Rather than running test cases, we might ask ourselves, is this true of the application? If so, we don't have to run that test case, and so on. Supplement test cases. Be able to say, this worked, this passed, this did not pass. Let's analyze why this did not pass via a checklist. Verify entry and exit criteria. Sanity checking. Are we doing things the right way? Are we doing things in a consistent way? Ambiguity reviews. Do we have any uncertainty here among team members as to what comes next? It can also help us in estimating a particular development cycle, particular process, to develop a particular feature, to test a particular feature, to integrate that particular feature, and so on. Once again, we can use checklists to help set up entire projects. We can look at application regression. If we're running regression tests, for example, we can look at how these regression tests actually reflect what we believe the application is supposed to do. We might look at graphics. We might look at browser dependencies. We might have a checklist saying, we don't care so much about this particular browser version, or this one's critical to our user base, and so on. Also, usability checks. Let's look at what we expect the user to do and whether or not it's actually seamless and easy to do from the standpoint of the application as it exists today. So what does thinking of failure accomplish? First of all, when we're thinking about failure, when we're thinking about disaster, constantly, maybe not constantly, but we're thinking about it on a regular basis, it doesn't come as a surprise like it does all too often for DevOps teams. Second, we have procedures and checklists to deal with those disasters, with those failures. We have practice in doing so because we've come up with our own scenarios, and in doing so, we practice how we're going to recover from that disaster. And once again, disaster, failure, whatever word you want to use, is just another day at the office. So I'm going to leave you with a final lesson here. And that final lesson is you as a DevOps team member, you're not alone. You are a part of a team. You bring specific skills, specific expertise to that team, but so do other people. Count on your team members. Count on your functioning together as a team to make disaster just another day in the office. Things will go wrong. Don't yell at people. Don't panic. Practice your non-conforming, your inconsistent situations regularly. Make up scenarios as unlikely as possible because they will happen eventually. If you have structured practice and those checklists and clear communication with your team members, it may make work boring, but they help when things start going wrong. You don't have to depend on a hero. You don't have to say, well, what do we do now? Use chaos engineering to test the resiliency of your application. The tests are in the public domain. The Netflix tests are in the public domain. There are other tests out there in the public domain. Read up on it and find out what you can do to test your application for resiliency. And use your experience to create procedural checklists to be able to, when something goes wrong, pull out a checklist and say, we do step 1 first, step 2 second, step 3 third. So once again, think back on the fact that I know at least some of you have flown here. Think back on the fact that commercial aviation is so much safer today than it was even 20 years ago. Why is that the case? It's because they practice and they have procedures for everything, and they communicate effectively. Thank you very much.